Hi guys, welcome to my YouTube channel. Today we'll be solving class 10th exercise 1.2 real numbers. Now the first question is easy. We just have to do the prime factorization for 140. So let's get started. So 140, we can write it as 2 into 2 into 5 into 7, which means it is actually 2 square into 5 into 7. 156, again we can start with 2 into 2 into 3 into 13, which will give me 2 square into 3 into 13. Moving to the third part, 3825. Now it's divisible by 5 or 3. 3 into 3 into 5 into 5 into 17. This will give me 3 square into 5 square into 17. Fourth part, 5005. This can easily be factorized as 5 into 7 into 11 into 13. Next we have 7429. So this will give me 17 into 19 into 23. All of them are prime numbers. Next, let's move on to question number 2. It says find the LCM and HCF of the following pairs of integers and verify this formula. Let's get started with that. First, for the HCF, we can use Euclid's division lemma. We can write 26 is equal to 2 into 13. So 13 gave me 26. So next I will write 91 is equal to 13 into 7. So here 13 gave me 91. So I will say HCF is equal to 13. Now LCM we can easily find out by using the common division method. Let's try that. 26, 91. So obviously we know both are divisible by 13. So I will get 2 and 7 here. So 2, 1, then 7, then 7. So basically LCM is 2 into 7 into 13, which should give me 182. Now let's verify. It says that HCF into LCM should give you product of numbers 13 into 182. This is 2, sorry. Should give me 26 into 91. So when we multiply both sides, we will get first this side 46920, and over here also 46920. So moving to part 2, let's first find the HCF. So in this case 510, we can write in the prime factors as 2 into 3 into 5 into 17, and 92 we can write as 2 into 2 into 23. I can see highest common is only 2, so I can write HCF is equal to 2. Next, let's try and find the LCM. Again, I can already see from here that whatever is needed I can get from the prime factorization. So LCM can be found using these two only. So 2 is common once, so I'll write it once, and rest will remain the same. So I get this into 23, which should give me the answer now, which is 23460. So we found the HCF and LCM. Now let's verify whether product of numbers is equal to HCF into LCM. So we'll get 2 into 23460 should give you 510 into 92. When we multiply both the sides, we will get 469 20 as well as 46920. So yes, both of the sides are equal. Part 3, now we have 336 and 54. Again, we can simply do the prime factorization of 336 first. We will get 2 into 2 into 2 into 2 into 3 into 7, and for 54 I will get 2 into 3 into 3 into 3. So here clearly I can see that this 2 and 1 3 I have common, so I can say that HCF is simply 6. So if I get rid of these two, then I can easily find the LCM. So LCM will actually be 2 raised to power 4 into 3 raised to power cube into 7. So which will give me 3024. So now let's verify that whether LCM into HCF is equal to product of numbers. 6 into 3024 should give you 336 into 54. So let's see, what do we get? When we multiply them both, this becomes 18144, and this also becomes 18144. So that's it for question 2. Let's move on to question 3. Now it says we need to use simply prime factorization to find the LCM and HCF. That's relatively easy. Let's start with the first part. Now in the first part we have 12, 15 and 21. I can write it in this way. 12 is equal to 2 into 2 into 3. 15 is equal to 3 into 5. And 21 is equal to 3 into 7. So it is clear that all of them have 3. So I will say my HCF is 3. Now whatever is left, first I will multiply it and then multiply it with 3. So my LCM will come out to be 2 square into 3 into 5 into 7, which will be 420. So let's move on to this one. Now 17 is simply 17 into 1 or 1 into 17. This is 1 into 23, and 29 is 1 into 29. So it is clear that my HCF is 1. Now for LCM, I'll simply multiply all three of them. I will get 23 into 17 into 29, which should give me 11339. Let's move on to the third one. So 8 can be written as 2 into 2 into 2. 9 can be written as 3 into 3. And 25 can be written as 5 into 5. As we can see, there is nothing common, so 1 will become common. HCF will be 1. For LCM, we will get 2 cube into 3 square into 5 square, so which will give me 1800. That's it for question 3. 4, he has given us the HCF of these two numbers and he's asking us to find the LCM. So we know HCF into LCM is equal to product of numbers, so we can say LCM is nothing but 306 into 657 upon 9. So I can easily solve this. We can either multiply and then divide, and my answer will come out to be 22338. That's it. Question 4. Now moving to question 5, it says check whether 6 raised to power n can end with the digit 0 for any natural number n. That means n can be 1, 2, 3 till infinity. So we are well aware that for anything to end with 0, it must be divisible by 2 and 5, right? So we must get the prime factorization of 6 raised to power n as 2 into 5. So let's see what is the prime factorization. 6 raised to power n, it will give me 2 into 3 raised to power n. So I can write it as 6 raised to power n is equal to 2 raised to power n into 3 raised to power n. It is not of the form 2 into 5, so there is no possibility that it will be ending with a 0, because to end with a 0 we have learned it must be of the form 5 raised to power n m into 5 raised to power n, where m and n can be whole numbers, right? So it will not give me a number which is ending with 0. Okay, so in part 6, let's first start with this one. This we can do it in two ways. I can take 13 common and I will be left with 7 into 11 plus 1. So 13 into 77 plus 1, which is 13 into 78 and into 1. So it has three factors, thus it is a composite number. Let's move on to the next one. Here we can apply the same principle. I can take 5 common. I will be left with 7, 6, 4, 3, 2, 1. So I can write 7 into 6 into 4 into 3 into 2 into 1 plus 1, right? So upon solving this, I will get 5 into 1008 plus 1. So this will give me 5 into 1009 into 1. So again it has three factors. It cannot be a prime number. It has to be a composite number. Okay. So now we move on to question 7. There is a circular path and Sonia takes 18 minutes whereas Ravi takes 12 minutes for the same. So they are starting at the same point. After how many minutes will they meet again? So basically we want to know at what time next will they meet. So we are looking at the multiples. So we must find the LCM of 18 and 12. We can find that by doing the prime factorization. For 18 we will get 2 into 3 into 3, whereas for 12 we will get 2 into 2 into 3. So I can see that 1 2 is common here, 1 3 is common here. So my LCM will become 2 into 2 into 3 into 3. So I will get 36. So after 36 minutes they will meet. So that's it for exercise 1.2. Please do like, share and subscribe to my channel for more updates. Thank you.